Testing, 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 testing. Okay, Assalamualaikum. Very good morning to all. Okay, so just testing mic. Can you hear me?
Yeah, betul.
All right, thank you. Okay, so I hope that everybody had breakfast this morning. And I'm not sure if anyone of you, any student who are affected by the flood, I mean, all around Malaysia. So if you are affected or you know your friend who are affected taking this class, then you just send me a message. I think those affected cannot access to class right now, right? So uh, just message me at the Telegram, okay? If you know anyone. Okay, so before we start, okay, while we wait for the other student to enter, okay, please go to ULearn and as normal, take the attendance, okay, first. And then I have uploaded the chapter 7 notes, electrical actuator notes, and also the Bolton reference for chapter 7, which is on the electrical actuator. And I have update the link to the week yesterday class, 20 December class. So please click that. While we wait, do fill in the form. So right now, if I refresh, only 6 students submitted. So here I can see who the number of students submitted. So out of 33, only 6 students. So please take like 1 minute to complete it. It's very easy. It's just asking about the midterm exam, okay, and the assignment. Okay, take 1 minute to fill it in. Okay, have you done fill in the form? Okay, all okay, 11 so already done that, I think. So let's continue. Yesterday I informed that I want to share about the assignment, right? So we just open the assignment. Um, okay, so can you see the slide? So this will be just a continuing, just additional briefing based on yesterday briefing on the assignment. So, and as you can see, basically in the okay, in the ULearn, I have sorry, in the form, feedback form, yesterday feedback form, is that I asked if what student have started for the assignment. So basically, I think students should have started to download every document in the ULearn assignment. So another tip is to be a student, a good student, is that when a lecturer update anything, edit documents in the ULearn or in MS Team, okay, download directly the document. Reason why is that sometimes I'm not sure for this semester how it will be continued later on, but normally PSTP, the one that handling the ULearn, they will close the ULearn to be accessed for student during during the during the study, I think during the final exam week, they will close it. Last time they mentioned that. But I'm not sure if they will close it again for this semester because they when they run the final exam online using the portal, they are taking spaces, much memory, so they need to close it from being accessed by student. So my suggestion is that even though it's already week 11, I hope that from week 1, when lecturer upload the notes to ULearn or to the MS Team, download directly and make yourself folders. Okay, you should have a folder according to your subject. As I have mentioned that earlier, I think a few weeks ago, about how to be organized. Okay, as a student, no matter who you are, as a student, when you were in secondary school during SPM or in a matriculasi or during STPM, you should have be organized. Means that more organized using 5S lah element. So by having a more systematic way to organize your files or folders, then you won't actually need to do last minute to compile everything. Okay, so you do it week by week. Okay, so week 1 you should have for example, in one folder, okay, you have BEKM2342 and you have folder week 1. Contoh example, and then you may want to label it week 1 dash the topic, what is it, introduction to Mechatronics system. Okay, week 2 example, dash is a sensor and a transducer. So it's easier for you to later on directly when you have the online exam, directly go to the folder according to the chapter that you know which the question is related. Okay, so this is how you do open book exam. eh? So to actually excel for open book exam, student actually need to be more organized. So you cannot actually don't download all the documents given by the lecturer. You just estimate that, oh, the ULearn is accessible during the online portal. So you're going to open everything during that time. Okay, so you will later find out that you will be opening so many tabs. You get confused and everything. So try to avoid that. Make a more systematic way on how to study. So that's a tip because as I mentioned yesterday, I think more what was let me look at um, the marks. So if you see here the marks of my student, okay, I have 33 students. So basically, okay, more than half of the student actually get more than 15. So that's good lah. Okay, only 10 get below half. So I think should be you still can improve on the way how you study. Okay, based on what you have seen in the midterm exam. And in the form also, I asked, if you have done the form, you know what I'm talking about. I have asked about why do you think you received that grades. So there are a few options that I put there. So you can tick that. Okay, be truthful. Okay, because I'm not going to judge you. If you get high marks, then I assume that you did everything. But if you get low marks, of course, you only did one thing only, which is maybe refer to notes, PowerPoint notes. Okay, you didn't do the other stuff, which is refer to the textbook, okay, that I shared, Bolton textbook and so on. Okay, so please remember for the final exam, basically we have MCQ question, multiple choice question, 40 question, and also you have a subjective question. Okay, so MCQ question will be kind of similar like what you have go through the midterm. So it was going to be hot type question because it's online mode. So it's not going to be direct. Direct means that you can just Google it or just search it in your notes. No, you need to apply what you have understood about the class. So for example, in sensor topic, you have learned about multiple sensor. So you need to understand the principle of why you use this type of sensor, why you use that type of sensor. Okay, so it's going to be something of more analysis level part. So you need to apply your understanding to answer the question. So don't do last minute revision. Please do it from now. Do your own notes and revise it. Okay, so for the briefing yesterday is that I have updated the task in Ulearn. Okay, and you have referred, basically you know that which case study that you need to answer. So they are from case study A to J. Okay, and in order for you, I have mentioned that in order for a student to actually get full mark, okay, there are students who get full mark for the assignment, and of course there are students who get 0 marks also. And you may wonder why student get 0 marks. 0 marks when we detect student copying from each other. Okay, so the two students get 0 marks automatically. Okay, so if you plan to get full mark for the assignment, which is 15%, so refer to the rubric. Rubric is how to actually get full mark based on the rubric. So if you answer to what the rubric, then you will get full mark. Okay, register and add yourself to turn in. Okay, this is important. Also, don't do last minute. I have given you the turn in link and the password to enter the course. Okay, so please, I hope that by yesterday, you should have logged in to turn it in and enter the class. So don't do last minute. Last minute means that tomorrow is the deadline, 31st December. 30 December, you message me, Doctor, I cannot access the turning in. I don't know how to access. Okay, that meaning late lah. Late, very late. Okay, last minute thing to do. Don't do that. Okay, so, and please do that. Okay, so if you look at the example, okay, in the case study, there are basically roughly about 10 case study. Okay, and this one is one case study that I'm going to show you an example, which is the problem is to design a real-time health monitoring system for patient implemented and tested at Clinic Kesihatan UTM. Okay, apparently, okay, actually this problem was given to, I gave it to my IDP student, integrated design project student, third year student last time, before COVID happened. Before COVID happened, I gave my student this topic. Okay, So basically, what it does is that I ask the student to design a health monitoring system for patient, which is when they go to clinic kesihatan, is that the patient normally, if you go to the clinic, what they do? They will check blood pressure. They will check your temperature. They will check your oxygen level, and so on and so forth lah. Okay, so what I suggest the student to design is that to design a system that when you do all of that measurement, it will automatically be compiled into under the patient name. So directly you have a history of data. Okay, so meaning that the clinic kesihatan have the data of everything under the system. So means that the doctor do not need to key in manually and so on. So they just put their hand in the blood pressure monitoring, and then directly that measurement will be saved to the system. So this is what I ask the student to do. So similar to the case study, if you see, there's a problem and student need to come up with a solution. So the solution is that for this type of solution is that, of course, if you look back at the topic that we have learned so far, we have 3 types of block diagram. First one is the measurement system. Second one is the actuation system. And third one will be the control system, okay, which is the overall block lah. So by having that knowledge, 3 block main thing, you need to apply that to this problem, how to solve the problem. So this is really important because later on, you will be a third year student later on, and you're going to do your IDP, integrated design project. So basically in that project, students are going to work in a group and you are going to solve a problem, and basically you need to come up with a product lah, a hardware. Okay, before you come up with the hardware, you need to design first, sketch it first, come up with what type of sensor that you need to use, what type of signal conditioning that you are going to use. Okay, if you need a controller, what type of controller, and how are you going to monitor it later on. So all of this you need to know from now, and that's why this subject, Introduction to Mechatronics, is really important for you because it's going to be used later on for other subject, for IDP, okay, for your final year project. Okay, so then don't take the class lightly lah, okay, even though it's all theory, blah blah blah, but it's really important. Okay, so the first task that is being asked to the student is to identify at least 5 functions required to execute the process. Okay, then identify the flow of energy, material, and signal going into and out from each function. Okay, so each function design, you need to describe how the function and flow relate to the problem. Write your answer in table charts and in following example. Okay, so you have a table right here. So you have a function and description and flow and description. So basically, okay, so if you look at this, okay, this is some explanation. So systematic design is what it means by systematic design is that you're not just simply going to design something without coming out organizing your thought, okay, your idea. So you need to do it systematically. Okay, so represent all the technical system as transducer interacting with world around them. So basically, when we talk about mechatronics, it's about having a sensor that can detect an output. Okay, so you need to have a sensor, for example, light sensor, motion sensor, what else, temperature sensor. Okay, so based on that, you can detect the temperature, for example, temperature sensor. Okay, so the system interact with the user and use environment by exchanging flow of energy, material, and signal with them. Okay, so all of this will going to be interact with each other. And the technical system is modeled as a transducer because it's built to respond in a known way to flow from the user from the user environment. This is user environment. Okay, so the function structure, okay, is a diagram produced by functional decomposition. So basically, what you're going to do is come up with the function and what is description and what is the flow and its description. So so what is it? Okay, so if you look at this function category, so we are going to talk about this first table first. So function category. You have function class over here. Okay, you have the basic function name. So under the class name is like a general term, general function. So, and then you have the sub, okay, of that class. So you have the basic function name and you have the alternate wording of that basic function. Okay, so, and so for example, okay, you want to you want to actually convert something, to want to rotate something. So if you look at here, is that rotate is under the class function of channel. So rotate is under the channel class, and for rotate is that another basic word for rotate is spin or turn. Okay, and so when we talk about rotate is that we're talking about actuator. And also when we talk about actuator, we talk about the actuator need to start. Okay, start the actuator, initiate the actuator movement and so on. So you see that there's a basic function over here is actuate, and it's all control magnitude. So you want to control what is the motion, okay, what is the temperature. So we talk about this control magnitude when we talk about a value. Okay, so you can go through all this function category. So where do you actually look at this all of this? So I have shared to you in the ULearn. Okay, remember there's a PDF which is name is important to read assignment guidance and reference tasks. Okay, so it's not there to simply for student to ignore. Okay, so it's over here in the notes, function representation. Okay, so if you have gone through, you understood what I'm talking about. So you know that there are few example of flow classes. We haven't entered yet the flow type of flow. So you will see that there's a flow, energy, material, signal, and so on lah. And we talked about function just now on here. Okay, so and in here is that how you're going to design the function block. Okay, so you have the flow just now, and you have the function. Okay, so function is the input output lah. So it's going to move and so on. So this is just a bit briefing okay, on function category. And flow type, as you see in the question, is that, okay, identify the flow of energy, material, and signal going and out from each function. So basically, you need to determine what is the flow, what type of flow do you need, and what type of function do you need. Okay, so flow is this one, function is this one. Okay, so what is function? What is flow? So flow is, you have three different flow example, which is energy, material, and signal. Okay, for energy is example is the one that you have learned on actuation. So you have hydraulic energy, pneumatic energy, mechanical energy, and for under mechanical you have the translational and rotational energy. Okay, so electrical is also energy, acoustic, which is on the ultrasonic, okay, thermal, temperature, and so on. So all of these are energy, and based on that, you might have the material. Okay, for example, for hydraulic, for pneumatic, is that the material that you are going to have the input and output is gas, compressed gas. Okay, so for hydraulic is compressed liquid. So those are the things that you need to understand, that there is a relationship between the energy and the material. And the signal is that normally the one that you receive from the output from the actuator or sensor. So what is it? Is it tactile, or is it visual, or is it auditory? Okay, so determine that. Okay, so let's look at the example just now, case study. Okay, so real-time health monitoring system. So what you need to do is that determine the function. So when you talk about to come up with the function, is that come up with the function that is related to the this one, related to the measurement system, actuation system, and control system. So for example, in order for you to detect the blood pressure, okay, example, so what sensor do you need? Okay, do you need any signal conditioning? If the signal is too small, so what do you need to amplify it? Okay, and data presentation. So what do you need to actually monitor the data? So you need a display, or you need for example, the data, raw data, you can collect it later and plot it as a graph. So measurement system, data presentation. Okay. And for actuation system, example, for the case of this case study, mostly there's no actuation system. Okay, so actuation system, we have that. We have the pneumatic. Okay, since you have the blood pressure, so blood pressure, you know that you are going to pump it and then make sure that it's going to grip your hand. So you have the pneumatic actuator over there, actually. Okay, and compress the air. And next is control system. So you need a control because the blood pressure machine need to control. Basically, when it detect the maximum, then it will stop and will calculate the blood pressure. Okay, so based on that, determine what is the function that you need. Okay, for example, detect pulse. Okay, for example, we take a very simple one, sensor just now, sensor. So you have a sensor. So the function is to detect temperature. Okay, look at this. So you want to have a function that to detect. So you can find the detect is over here somewhere. Okay, so detect the temperature, which is the flow there. Okay, so what is the flow? So the human is going to place finger on the temperature sensor. Okay, so that is the flow, means that in order for you to detect it, then what required to be done? Okay, so come up with that. So based on your answer, okay, don't follow this example. This example is too many. What I asked is only 5, which is represent this main thing only: measurement system, actuation system, and control system. And it need to be reflecting to what you learn in class. Okay, for example, push button, no, don't do this. This one is for IDP example, they have this. Okay, LED on, no need. Okay, you take the one that is representing to what you have learned in class. Only on the measurement system, the actuation system, and the controller only. Okay. Okay, and so based on that, the second question is that to design the functional block diagram. Okay, so design the functional block diagram. If you look at here, okay, I'm not going to explain full, but you need to read through the PDF that I gave to you. Read it all until finished, all the 12 pages. So after you read through, you will understand how to actually come up with the block diagram later on. Okay, so this is one. Okay, next is on the okay, after you draw the block diagram for the individual block diagram, then you're going to draw the full block diagram. Full block diagram is after you combine everything. Okay, so same goes to in this example. Okay, actually in this example is, you see that initially they draw the block individually like this. Okay, and then later they combine it into this large block diagram. So this is how you need to actually represent the block diagram later on. Okay, you can draw it one by one, up to you, and then you can combine it and come up with the combined block. Okay, task number 3 is on analyze the suitable mechatronic component to perform each function. So when you are answering this question, is that this is going to reflect to task 1 and 2. Okay, that's why task 1 and 2 is important, that it need to reflect to what we have learned. Okay, so an option 1, 2, and 3 is basically the option of example, option of sensor, what type of sensor you need to use, or what type of signal conditioning you want to use, or what type of data presentation, or if it's talking about actuation system function, then what type of actuator you are going to use, plus the mechanism. Okay, so don't forget, in the actuator system, you always need to combine it with mechanism. So think of what are the mechanism required. Okay, and after you list all the 3, then justify between 1, 2, and 3, which one is the best and why. Okay, don't answer which one is the best because of cost. No, don't take into account the cost, okay, the price, no. Take into account why it's important in terms of the sensor or the structure of the component. For example, if you talk about a sensor that can detect obstacle, so you might want to have infrared sensor, ultrasonic sensor, okay, or light sensor example, okay. So which one is the best? Why do you think is the best? Okay, so you want to explain that. Maybe it's because of the material of the object. Material of object, for example, if you have a water bottle, can IR sensor detect this obstacle? Okay, so is it can reflect or does it not reflect? Okay, so think about that and why you justify it. So you can talk about the material. Might be you can suggest if it's a different material, then it's best to use ultrasonic sensor. Okay, so okay, this one is example just now. If the function is to actually convert linear to rotary, number 4 here. Okay, 1 to 3 ignore. I'm talking about number 4 ini. Okay, so you want to have a 4 balik, option 1, or you want to use a slider and crank mechanism, or you want to use a rack and pinion. So which one do you think you want to use for your system or design? Which one is the best? And task number 4 is that you are going to draw out the component. Okay, so let's say that you have the component everything. Okay, you are going to label everything, where is the sensor and so on. If there is a mechanism involved, then you need to draw out the mechanism and also draw out if you're having actuator. Okay, actuator. So how does the actuator and mechanism connected? Okay, so it need to be clear how you're going to design it, right? Reason why this is important is that in final exam, question will be not similar, but if you manage to answer the assignment, then I'm sure you will able to answer the final exam later on. Okay, so and lastly is that task number 5 is that to explain the working principle of the system. So after you have designed it, explain everything about what are the options and what are the sketches of the design, then you're going to explain the working principle. So you can just explain it in terms of numbering. Number 1, what does it do? Okay, when the sensor detect blah blah blah, the actuator will blah blah blah. Okay, and so on. So you're going to explain it based on the task number 4. Okay, so any question? Any question? No? Hello? Okay, ada. No question No question, then it's okay, no question. So then everything is clear. Okay, so
Untuk yang apa block diagram kan? Kan yang mula-mula kena buat apa satu-satu tu kan? Nak kena buat semua ke macam mana?
yes. Based on
Kalau
the
ada
task 1, 2
kalau ada
and 3.
10 lah.
Yes. If you have 5, then 5.
Oh, okay.
Whatever you answer in task 1 and 2 and 3, you need to define it in the following. Okay, you cannot explain in the first one is that you have the function any, and then you just ignore it towards the task 3, 4 and 5. Okay, it need to be related. Reason why, if when the lecturer mark the assignment, okay, we found out that it's not related at all. You're answering task 1, 2, 3 is different from what you draw in the sketch and explain in the task 5, the working principle, then you won't get marks. So we are not going to mark it based on, oh, you listed everything. Even though we asked you to list 5, but sometimes you student will tend to list more than 5 lah. Okay, when you list more than 5, if it's redundant, if the function is redundant with each other, then we consider only 1. Okay, so don't put redundant function. Put the one that represent your system lah. You don't need to put everything flow, just the roughly the system. Okay, so I would suggest when you answer the I would suggest when you answer the case study, okay, actually if student bijak, okay, you're not going to do from task 1 to 3 to 4, 5, you should be doing from the number 5 first. Why? Because you need to think, how does it work? Do you understand? So if you cannot think how the system work, then how can you imagine that what sensor you're going to use? So student, tip. Okay, because the question is to of course, if we give you the case study, for example, let me see. Okay, for example, okay, remember this? I think you seen this example before. Okay, I have shared in class during, I think week 1, 2 or 3. Good. I gave you one case study and then I also give you a video. This one is actually taken from my final year project student. He did a project on designing a wearable automatic lower limb rehab system. Okay, so the case study G is doing that. Okay, so what you need to do is that the system need to have the following specification. Okay, so you need to have the mechanism where at the CT position. So why it's important to explain that? Because I don't want student to actually, patient is going to stand up and do the exercise. No, that's not the idea. The idea is that student need to rehab their lower limb. So they need to sit down and put exercise to the foot there. Okay, so and of course the wearable system must be light. So that one is just additional information. The one that is important when you look at the requirement is that think about what are the sensor, what are the measurement system required. Okay, don't think about push button kena. No need. That one is no need unless you're going to design the full one prototype and so on. We are want to test student on the topic of introduction to mechatronics. So we want to test student on the measurement system, okay, on the actuation system, and on the control system. Okay, so we want to see for the control system what type of controller or what type of reference that need to be controlled. So we want to look at student understanding on the block diagram. Okay, so use a mechanism that able to convert from linear to rotary motion. Okay, so means what? So you need to think, mechanism, convert from linear to rotary. Okay, there are lots of mechanism linear to rotary. So which one is the best? So you need to do some research first, background dulu. Find out what, I already explained in class, right? So linear to rotary, there are few lists of mechanism. And specific why? Because you see, actually this one is when they do the exercise with the rotary motion. Of course, if I do not put this limit, the student will directly do not use any mechanism. They directly use an actuator that can rotate. Okay, so for this one is that when you have the mechanism, so you need to have what? You need to have actuator. So when you have the actuator, then you need to read again the statement. Use a mechanism then able to convert from linear to rotary motion. So where do you actually install the actuator? Is it at the linear part or rotary part? That one is student need to think. Rehab for the joint bending at 90 degree. This one is where the controller part is going to be involved. So what are the reference that you need to control? Okay, is it temperature? Is it position? Is it linear motion? Is it rotary motion? And so on. Okay, and it says here that you need to control the speed. Okay, add a mechanism of the mechanism at a value. Okay, for extending and retracting. Okay, So it means that what? You need a sensor. So just when you look at your case study, think about that element. Okay. So it's really actually it's direct. Okay. If you understood the class, okay, the question is that you need to have all this measurement system, actuation system, and control system. Okay. So I mentioned just now is that go through the assignment from task 5 to task 1. Means that, of course, the flow is that you need to do 1, 2, 3, 4, 5. Okay, in the assignment. But when you get the case study, what do you imagine? What do you imagine? Oh, okay. I imagine if I were you, I imagine that, oh, I'm the patient, then I need to do all this requirement. Okay. So I need to do all this requirement. I need to wear the mechanism at my waist. Okay. I need to actually push on it, and then all of this. Okay. This leg will actually move up. Okay. In rotation. So basically, this leg will move up like this. Okay, in an angle 90 degree. So it's going to rotate 90 degree. Okay, even though this, it looks like it's doing a linear motion, but we are not talking about linear motion right now. You need to follow the requirement that being asked. Okay, so read carefully. Okay, and when you read the case study, imagine that you are the person or the patient, or if you have other case study, then you are the person that have the problem. Then you want to solve the problem. Okay, so what type of sensor actuator are required? So in order for you to do that, of course, you need to be able to explain the working principle of the system overall. So just now I will explain that, oh, I'm going to sit, I'm going to push my foot in an angle like this, rotation. So it's going to rotate 90 degree like this. Okay, with a speed of the value that given. Okay, so it's going to do rotation. So you know that for stroke patient, they cannot control their feet, okay, because stroke. So the machine will help the muscle to actually rehab. Okay, so improve itself. Okay, so that's why it's going to be very useful for rehab patient. All right. So think about this first, number 5. Then do a reverse lah, basically reverse engineering. So after thinking about it, then you think about what are the how does it work, and after that I will go to this one. Basically, I would like to know, okay, what are all of this? What are the sensors being used? Of course, the one that we ask is only 5. Okay, so you might want to have only this one kan, because it's all one. This is 1, 1, 1, 1, and 1. Okay, 5. All right. So, and after having listed all of those things, then I'm going to go to the number 3. Okay, list out everything and sketch it. Okay, and you can go back to the first one, and based on what you have selected here, just reverse engineering and write out what is the function and flow. Okay, so you can list, the minimum will be 5 function. Of course, you can do more lah for more exercises. Okay, no worries. If you do more, then should be better marks lah. Okay, but do not actually put there redundant. Okay, redundant answer. Okay. So is it clear? Siapa tadi tanya soalan Okay. Any more question? Because you have roughly 2 weeks to settle the assignment, so don't do last minute task. Okay. Okay. Based on that, 9:44. Okay. 9:44. Okay, we are going to go to the, oh, okay, there's a question in the chat. Sekejap, I tengok. Madam, for the function, can we give more than 5? Yes. You can give more than 5. If the function if the function wrong, will it reduce mark? You can give more than 5. If the function is wrong, no, you get no marks only lah. I'm not that strict, when it's wrong, I give you -1. Okay, no such thing, so I'm not going to give you -1 if it's wrong. So but basically, don't list out rubbish lah. Okay, it's not saying that having more function is a good idea. Okay, but if you have more, because some case study, I'm sure it will be more function because you might need more than one mechanism. You think that you need to have more than because in the question is that you need either electrical actuator plus mechanism or pneumatic plus mechanism or hydraulic plus mechanism. So you might think that for your case study, you need to have 2 actuator. You want to have an electrical and also you need to have the hydraulic. So why not? So you can explain that if you want to. Okay, and same goes to sensor. If you think that it needs more, then list out. Okay, because as I mentioned, the explanation of task number 5 is to explain the working principle of the design. So basically, you cannot skip. If it must to have all the function, then you need to list it out. Okay, but list out the one that relevant to our topic in this subject. Okay, Tai, any more question? No? Okay, if no, before we go to this chapter 7, because it's already 9:45, I want to, I think you have your notes, but I'm going to just play it for you. Okay, in the last slide number 44, I think maybe for you it's not 44 because my slide, I have additional slide. But you can go to one example. Sekejap. I unshare again because I share without sound just now. Share. Okay, let's look at, how it's made. Okay, I'm not sure for you guys, but I like to watch documentary at home. I have Astro. I don't have Netflix. Astro pun tak habis khatam lagi tengok. So, but I like to watch the documentary. Most of the documentary is how it's made, a big machine and so on. So I hope that you guys also similar, being an engineering background. So you need to have that passion of watching all those type of video. Okay, if you don't have that passion, then I'm not sure lah later on how you're going to work, because you need to understand because maybe you're not going to work in that field later on, but you have an idea how to actually how does the mechanism work.
Setiap hidangan itu istimewa.
Can you hear?
Ya,
Okay. Let's just watch this about 7 minutes. Watch together. Ni biskut. Sorry. Macam mana pula? Biskut dah. Okay lah. Memang biskut pun. I think it will be too long. Okay. Let's look at another video. You can watch that on your own. Sorry about that.
It's hard not to wax lyrical about crayons. They were invented in America in 1903, when a non-toxic version was created from the basic wax crayon already used for marking crates and barrels. We take a look at how colour is added to childhood. These crayons are made from a combination of waxes, primarily paraffin, which is ideal because it's inexpensive and easy to melt. It also has what's called a nice rub-off, meaning it leaves enough wax on the paper. The wax is melted to 62 degrees Celsius. Then a secret powder is added to strengthen the crayon and act as a filler, boosting the number of crayons the wax will produce. Various synthetic chemicals are also added. There's one to keep the wax from sticking to the mould, and a fatty acid called stearic acid to improve the rub-off. Now the wax is tinted. In this case, the addition of yellow and red produces orange crayons.
Okay, a tip when you watch this type of video, try to think about what type of actuator is being used, what type of mechanism, what type of sensor, okay?
This factory can produce 127 different colours. Every ingredient in the crayon is non-toxic. After adding more wax, the mixture is blended for about 45 minutes. Now the wax is pumped into this device, called a rotary machine. It first injects the wax into crayon-shaped moulds. Then, it envelops the moulds in cool water, hardening the wax within 60 seconds. As the moulds continue along the circuit, a blade scrapes off the excess, which gets recycled. Just one rotary machine moulds more than 2,700 crayons per cycle. With several machines operating simultaneously, this factory churns out 30,000 crayons every hour. The machine ejects the crayons, and a conveyor transports them to the labelling machine.
Okay, look at what type of mechanism
One by one, they drop into the
actuator being
grooves
used,
of a revolving drum. At the bottom left, glue coats the surface in between the grooves, just before the crayons go in. The machine then slaps a label onto each crayon. A roller presses the label against the adhesive. Then a small arm wraps it around the crayon. This machine labels 8,500 crayons per hour. The crayons exit the labelling machine and land in a box. They're sorted according to colour into the appropriate hoppers of the packing machine. The packaging line is entirely automated. The factory programs the machine to collect a certain number of crayons in specific colours,
automated,
according to the
so
type
you need
of
to have a
packing
controller
production.
or
Their
sensor
best
to count.
sellers are packs of 16 and 24. The packing machine is designed to handle the crayons gently. Occasionally, though, a crayon does crack or a label comes loose. When that happens, a sensor automatically stops the machine and a light goes on above the problem hopper. The jam is cleared, then production resumes. Once the count is complete, the crayon line and the box line meet. A pushing device slides each set of crayons into a box. A built-in scale weighs every box. Should one be underweight, the machine automatically blows it off the conveyor belt. Then the missing crayon is added manually, ensuring a full complement of colours.
Alright, so based on that video, lots of actuator. Okay, you can find that first is that there are lots of actuator being used. Okay, so what do you think? What are the actuator are being used in the video just now? You can write that in the chat. What type of actuator? Actuator. Not the mechanism. Actuator only first. So what type of actuator do you think? So write that in the chat. Okay, chew, pneumatic. What else? Pneumatic. Okay. Lagi? Liu cakap electric. Okay. Who else? Even though you cannot see actually, but what do you think? Mechanical, I'm not talking about mechanical actuator right now. I'm talking about mechanical actuator is normally used with the three actuator. Mechanical plus electrical, mechanical plus pneumatic, mechanical plus hydraulic, and mechanical plus tak adalah. Okay, 3 saja. So the rest, no idea. Berapa orang je jawab ni? 1, 2, 3, 4, 5, 6. 6 je. Lagi 27 more student? Electric. Okay lah. So you guys do not know much, So basically, when we talk about industry, when we talk about large mass production, so most of the actuator that is being used is not electrical actuator, because if you see just now, it's you have like large molding, molding process and so on. So they either use pneumatic or hydraulic. Okay, the one that they I think they will normally use hydraulic most of the time, because pneumatic is difficult to maintain because you need to have a compressor and so on. And if you lose the air, then it's going to be a bit difficult lah. But hydraulic is that it's only leakages, so they can actually fix the leakages easier. So mostly will be hydraulic. And what type of mechanism do you think you can see that in the video? The one that you have learned. What do you think? Mechanism. Type of mechanism. Lots of mechanism. Write there in the chat. Chain belt mechanism. Okay, good. Yes. One is it is the chain mechanism lah, chain and belt mechanism. You can see that in the conveyor or some of the when they need to rotate. So you see that they link lots of shaft together. So they use belting and gearing inside there. So when you have the belting, then most of the time you have a gear mechanism. So what else? You can see that there's lots of conveyor bringing the crayon from point A to point B. So basically, when you have a conveyor, is that you normally have a bed drive system lah, and also you need to have a belt mechanism. And linkages is also a lot there. If you see that you have the rotation, when they need to scrap the crayon, they rotate the scraper and so on. So linkages is there. Lots of linkages inside the production line. So basically, what I want to show just now is that later when you work or when you do your LI lifetime industry, okay, you are going to do it in the company or industry. So and you will find out that in industry is nothing what you have seen in the university. Okay, in the university you learn about theory. Okay, theory and so on and so forth. And if you actually a good student, you will notice that what you have learned in the university, in classes, lots of it can be found in the industry. Example that I showed to you, if you're working at the crayon factory, you will see that, oh, this is what Mariam is talking about, the backdraft mechanism or the gearing system or blah, blah, blah and so on. So this one is why student, please do not, after final exam, you delete all the memory from your brain. Don't do that. Okay, and don't delete everything or give your notes to your junior and so on. Please keep it until until you graduate, because you might not know later on where you are going to work. And you'll find out that when you start working, okay, this is the tip, is that company do not care if you don't know, if they're not going to train you on what to do. They expect that when you be an engineer, you know everything. And of course, you are a junior, junior engineer. So, but they will expect that you know everything because you receive the salary as an engineer. So, and they might give you directly a project to lead or to do or handle. And if the project is something like this, a case study, okay, go and install something on for example, the case study just now on to come up with a design for a rehab patient for rehabilitation. So you're going to be shocked that you need to submit the proposal next week. Okay, and it's not like in the university. In university, we give you assignment or submit in 2 weeks and so on. In industry, they give you a task today. Tomorrow, they want to see the output or the presentation or the whatever graph. Okay, so the result is tomorrow. They want to see it. So don't be shocked later on when you go for an LI, is that it's moving very fast. They're not going to wait for you to learn. Okay, so everything that you need to know should be learned during your study here in the university. Okay, so don't forget everything after you graduate. Please keep it in your brain. So that's my tip to student. Okay, if not, you will have a hard time to actually cope at work. And this is why lots of the time you will see that a new fresh graduate cannot cope with the industry. They, after 1 week of joining the company, they left the company. Tak tahan. Okay, tak tahan. You know, you cannot be that. You need to be robust. Okay, if you want to be an engineer or if you want to work, basically, need to be robust. You know, like let's say like as a lecturer, okay, do you think working as a lecturer is easy? I just want to ask question to student. Okay, in the chat right there, do you think working as a lecturer is easy? Right there in the chat. Yes, easy. No. If yes, then right there, easy. Why you think it's easy? I want to know what's your thinking. Okay. No. No, semua jawab no sebab takut nak jawab. Okay. Basically, back when I was entering UTM at 2005, it's not easy. You know, I graduate master 2005, and then I joined UM for a while, for 1 month, and teach part time at UM. Then I get a permanent at UTM lah as a lecturer. So, you know what happened? I just share to you guys. What happened is that when I entered UTM, in July. I remember it was in July 2005. When I lapor diri, we go and register lapor diri at the dean. The dean will say, okay, Mariam, you're going to teach this subject, electromagnetic theory. Okay, so if you are electrical engineering student, you know that electromagnetic theory is a very difficult subject to learn. Okay, and to teach is more difficult because in order for the lecturer to teach student, to make student understand, we need to understand, okay, the concept and all. So I need, when I need to teach, I need to teach that week. Okay, I just register, enter UTEM, and I need to take a class, electromagnetic, and the class is this week. Okay, so imagine that. Okay, so how are you going to cope with that situation? So different people, different way of coping. And Alhamdulillah, I actually thought electromagnetic difficult subject. Every difficult subject was passed down to me. Signal system, difficult subject also. But right now, I like to teach signal system. So I have teach signal system more than 15 times good. So it's already embedded in me. So this is how you need to cope later on when you work. They will assume that you have the qualification as an engineer, okay, mechatronic engineer, and based on your background, you should be able to do this and that. Okay, so this is what my tips to you guys lah. So I think we take a break for a while. It's 10:06. We take a break 10 minutes and we continue the class on chapter 7. Okay, but before that, please go to Padlet. Okay, go to the Padlet task. Okay, Padlet here. Sorry, Padlet mana? This Padlet. So in the Padlet, I have actually updated list of activity that you are going to do this week lah. Maybe this week and next week lah. This week, so there are 4 activity for the chapter 7. Okay, so just go through what are the activity that I asked the student. So don't do yet. Just read through this activity, and based on this activity, go to the slides that I upload in the ULearn and go through the slide. Just go through. Later at 10:15. I'm going to start with the chapter 7 PowerPoint slides. Okay, that's all. So see you guys at 10:15 lah. 10:15. Alright, that's all. We take a break. We take a break. Okay. Are you in? Okay. All right. Okay. Just a reminder, those who maybe didn't attend my class, okay, due to any reason. So make sure that if you didn't attend, go to the recording. You know that I link all the recording to the Ulearn. So go to the recording and watch the recording again. And if there is some task given during the class, then try to answer the task also. Okay, so because I was going through the Padlet, let me just open the Padlet. Okay. Last time I gave students some activity, this one. Okay, later when we finish I will try to finish this chapter and chapter 8, control. Then we will backtrack and go to the discussion that we haven't discussed yet. So example like the this one week 8, we talk about lots of mechanism that time. So and one of it is that I asked you to watch the mechanism of the sewing machine. So the sewing machine, I see that lots of you guys already label it everything. So later we will try to discuss is it correct or not. Okay, and I hope that, I'm not sure if everyone did upload, but it should have 33 submission. Okay, I don't think this is 33. So if those who did not yet submit the task under each tab, please do it. Okay, even though there's no marks, this is basically a formative assessment. So formative is basically something that student are not giving marks, but if student do this task, you are going to learn more. You will add on your knowledge when you do this task. If you don't do, then you simply do not understand how does a sewing machine work. And in a sewing machine, you see that there's lots of mechanism inside. Okay, after you watch that, then I think if your mom's or grandmother sewing machine is have problem, then I think you can repair it. Okay, you can try and check which mechanism is is having problem. Okay, so let's go to the slides directly. Okay, the first one is okay. So for the learning outcome is going to be mapped to LO2 and 3. Okay, explain the working principle. So if you see here, every chapter from chapter 1 until chapter 7 is all about you are able to explain the working principle. Okay, LO2. And this is where when you look at the midterm exam, so midterm exam is basically mapped to LO1 and 2. So LO1 is the explain basic concept of mechatronics. So basically it's kind of a direct question. But if you do not study, do not read the Bolton book, then I think you cannot answer, because the answer is mostly somewhere in the Bolton book, and the notes. Okay. So number 2 is that explain the working principle of mechatronic system. So based on your understanding on the concept, then you be able to explain the system. So maybe in a midterm, if you see in the midterm exam in part 2, which is mapped to LO2, you're given some kind of picture or case study or diagram, and you are asked what is the principle of that mechanism. Okay, so what sensor it detect and so on. So this is where you need to know, for this type of diagram, you have a camera, so what detect? What does it detect? Okay. So so for this chapter is that you are able to explain the difference between electrical actuation system. So there are lots of type of electrical actuation system. So how does it operate and what are the applications? So types of application that I mentioned just now, one of it was the crayon. Well, a crayon, most of it are hydraulic, but maybe it can use electrical motor. Okay, it's up to the company to use, but most of the time they will need the torque, the required torque. So if they want a larger torque because of the molding process and so on, they prefer the pneumatic and hydraulic. And And the one that I showed, which is much more relevant, is the power steering. So power steering, they use the mechanism plus the electrical motor. So if it's the normal steering, the manual steering, you have only the mechanism. That's why without power steering, the car is really heavy. It's very heavy to stir. Okay, so if you have a electrical motor or hydraulic actuation in that car system, so it's easier to actually handle the steering. Okay? So back again to this. Okay, so just a recap. Okay, you have covered the measurement system, and in the measurement system, you have learned about the sensors, and also the signal conditioning, and also data presentation. So data presentation, where is it? Normally, data presentation is after the signal conditioning. So it might be that you are going to save the data, or you want to display it somewhere. Okay. And for the actuator system, you have the actuators, so hydraulic, pneumatic, electrical, and you might ask, oh, where is the mechanism? So mechanism is also here included in the under hydraulic, pneumatic, and electrical. And in order for the actuator system to detect the signal from the controller, you might have the digital to analog converter or digital to analog, digital to digital converter. It depends on the system. Sometimes you want to change the sampling time. So you want to use digital to digital because you want to change the sampling time from smaller sampling time to a larger sampling time. And if the signal is small, then you want to amplify it, and you might want to have to control the speed, you want to have a PWM. Okay, so you don't need to have a hardware, you just need to tweak with the signal. Okay, so this is where signal conditioning. And where is the data presentation? Most of the time, I think for the actuation system, no data presentation, so it's under measurement system. And the overall block will have the control block. Okay, and output will be here, output, and it's going to be feedback compared with the input reference. Sometimes in a book, control book, it doesn't have shown the input reference. Okay, it shows that only reference. What reference means is that, example, you have a car. You have a car that can actually control the speed. You click on the button, then the speed of the car will be maintained at 120 20 km per hour. Okay, so the reference that you set at the initial part here is 120 km per hour, basically. Okay, so okay, so this reference will be 120 km per hour. Okay, so this reference. And output is the one that you read in your console, the car. Okay, you might see that, oh, the car console is 121 km per hour. Okay, so it means that there's an error there. So it's going to compare here. So you have 121 km per hour. So the error is 1 kilometer. 1 km per hour plus. So the controller here is actually to regulate, to control, and to reset so that you have the reference and output is the same. So it's going to try to change the input, the control signal. So the signals going out from the controller, we call it as the control signal. Okay, and this is where the control signal will be amplified. Sometimes because it's too small, so you want to amplify it so that it can be read by the actuator. Okay? So this control signal, after it amplified and everything, then this reading will go down to 120 km per hour. Okay, so if it goes down to 100 km per hour and it maintains, means that the controller able to actually control the system. Okay, so then the error will be 0. So this is how it works. Okay, so we talk about the input for a closed loop is reference. Okay, so okay, we jump that. This one, just recap, just read it. Okay, so we go to here, this part. So types of actuator, we have covered for the pneumatic actuator, the hydraulic actuator. Okay, and now we are under the electrical actuator. So under electrical actuator, you are going to go to the 4 main component that we have. Of course, under this component, we have other stuff also. We have the we have the brushless DC motor and so on. But this is the common one that when people talk about it, then you as a student, you need to understand what is the difference between DC motor, servo motor, stepper motor, and also AC motor. Okay, so first one is that you need we go to the element of electrical system in control system. So we have three types of element. So the first one is switching devices. So switching devices is something that you normally see in a small in a simple system. So it act as a control signal switches or on and off some electrical devices. So example is relay using solenoid. Okay, so mechanical switches. So it's going to control on and off. And sometimes when we talk about relay, okay, if you are going to learn PLC, so programmable logic controller. So programmable logic controller PLC. They have also a relay, but in terms of program ladder diagram. So later, that's why nowadays when we talk about electrical system, sometimes if you want to control something easier, then you apply a PLC system, PLC controller. Okay, PLC controller, the one that you see, example, in washing machine. Okay, you have a PLC controller. In vending machine, you have a PLC controller. Where else? Traffic light, you have a PLC controller. You know, in Malacca, we have lots of traffic light and lots of countdown. So when we have that countdown, actually, you have the PLC controller automatically, because it's going to count down. And the one that you notice that is that when you are at the traffic light, do you notice that when you are at the traffic light in Malacca or anywhere else, if you are not sitting directly at the front line there, okay, the traffic light won't change to green. Okay, so ada kan? Basically,
banyak tak?
What do you think? Why do you think? Kenapa rosak traffic light ni? What do you think?
Dia ada sensor dekat jalan tak silap.
Okay, where is
Ada
the sensor? Where is the sensor?
Apa benda kan?
Where is the sensor? Anyone? Ini you guys kena tahu why.
Kamera.
And kamera, kamera tak boleh lah. Mahal sangat tu nak detect. Okay, unless you ada AI lah. You ada AI, artificial intelligence, then the camera can detect the car and so on. So you will detect. Okay, Louis cakap top of the traffic. Top of the traffic tu maksud dia apa? Ada traffic light ke? I mean, ada traffic light pole ke? Or on the ground ke? Or at the side ke? What do you think?
Dekat ground.
Ground, right. It's actually on the ground, inside the ground. If you notice, at each of the traffic light, you see that something like macam ada cut off kat ground tu tau. Tar tu macam lain macam sikit. Sebenarnya dia embedded a sensor. Load cell is underground. So that load cell is connected to the traffic light. So it's a sensor basically. So that's why if you found out that sometimes I'm in a traffic light I'm really stressful when the person in front is not sitting on top of that cut off tau. Especially when motorbike. Okay, motorbike when they sit there, don't detect anything. It's too light. Okay, so basically what I do is that I horn sikit and I ask them to move aside lah. Okay, move aside so that my car can be on top of that spot. So that's why those who are riding motorbike, make sure that you don't sit in the middle of the road at the traffic light. Sit at the side so that the car can actually stop at the sensor. Okay, if not, you will find out that your line is not going to turn green forever, basically. So be alert on that, and tell your friends or your family members. Make sure that if you look at the ground, there's a different color of the tar, then there's a sensor underneath. Okay, so this is switching devices. Second one is that solenoid type devices. Okay, so solenoid type devices, and this one I have explained previously in the hydraulic and pneumatic controller, you notice that there's a solenoid kan inside the hydraulic and pneumatic to control the valve open and close. Okay, so this is it's embedded in the pneumatic and hydraulic. Okay, and of course in electrical they mostly use solenoid or electric current. So it's using the electromagnetic field. And the third one is the last is the drive system. Okay, so the drive system is basically to make it rotate or to move in linear motion. Okay, so it can be DC and AC. Okay, so before we go too deep on the types DC motor, stepper motor, and so on, so this one is just a refresher. Okay, on the hand rules. So you guys can go and watch the video, but I'm going to directly explain on the hand rule. So we have the right hand rule. I think most of you know this. So right hand rule means that, okay, so it means that if you have this is the current flow moving up. Okay, so basically your thumb is the current direction. So you have the wire. So you put your fingers, the 4 fingers around the wire, and make sure that the thumb is moving in the direction of the current. So this will mean that, okay, the direction of the 4 fingers here is the direction of the magnetic field. Okay, that one is the basic concept of the right hand rule. Okay, current versus direction. And when we talk about actuator, it's using the combination of right hand rule and Fleming left hand rule. Okay, so Fleming rules, they have 2 types of rules: Fleming left hand rule and Fleming right hand rule. So what's the difference? So the difference is that you might know that previously you learned about the Fleming left hand rule. Okay, so Fleming left hand rule is for the motor. Okay, basically it's for the motor. Okay, for Fleming right hand rule, okay, you use the right hand, but with the same point of the fingers, the 3 fingers, is for the induced current. Okay, so what does it mean? So basically, for motor rule means that if you have a DC motor, we have a stepper motor, so it's going to use the left hand rule. So the rule is that the motion is using the thumb. This finger is the field direction, and the current is the third finger. Okay, and all of it must be perpendicular. Okay, this one is in electromagnetic theory, we talk about this one, perpendicular. Okay, 90 degree. So all of the finger need to be 90 degree, 90 degree. So when we have that, then you will learn later on in the next slide is that when we have the current in this direction, for example, in this direction, okay, and you have the field in that direction, then the motion will go up. So that's why the motor can rotate. And for the Fleming right hand rule is for the induced current. Induced current means that, okay, for motor rule is that you give current, you give motion. For induced current, Fleming right hand rule is that it's the opposite. You give motion, you will achieve a current. So basically, it will induce current. Yang kat motor rule is induce the force lah, basically motion. Okay, so you can go and look at this video later on. So how about solenoid? So solenoid is using the concept of right hand rule. Okay, right hand rule, not the Fleming rule, right hand rule. Okay, right hand rule, you know, just now is based on one wire. Okay, one wire, your thumb is moving up. Okay, so basically you just grip the wire, then this one will be the direction of the magnetic field. So when we talk about solenoid is in a ring like this. So basically macam ni lah. Okay, so many wires. Okay, so let's imagine that this one is the direction of the current. Okay, I. Okay, direction of current. So you just grip. Let me just delete that. I want to change the direction of the current. Current is like this. Okay, so I just grip the current. Okay, is the direction of the current. So what happens is that you have the magnetic field in this direction. So basically, the magnetic field is moving out. Okay, moving out. So out, this one, the indication. So if direction current is in, then it's have this cross, and out is you have the dot. Okay, so moving out. Okay, so if you have the current in this direction, then your field is moving in. Okay, so that's why you see that over here. Okay, you have the field in this direction, then you have the magnetic field in and you have the motion or magnetic field in this direction. Okay, so and this concept of solenoid is applied to a relay basically. So if you see here the relay is this one. Okay, so you imagine that you have the current here. Okay, so what happened is that I think this one is the positive and this is ground. So you have positive and minus, so it's in this direction. Okay, so you have this direction, so in moving down. So what happens is that you see that this term is the magnetic field. Okay, so it's going to actually pull this contact, is going to close. So that's why the relay will close. So how does it really work? I think you can read through how does it work, and I have shared to you the video here. So how does the relay work is that by actually inducing a current here flow, and it will then there will be a magnetic field and will actually pull this contact to close. Okay, so we are going to go through this one to the component of the actuation system. So basically we have three types. We have the motor, then we have the drive system, which is drive system comprised of the open loop and closed loop. Okay, open loop means that you cannot control it. Whatever you give input, it will give that output or motion. So you cannot control what is the output. Example, the car just now. Okay, a car, if you are a human, your human is the giving the input, which is you press the pedal of the car. So what happens is that the car will actually speed up according to how you control the pedal, kan? So we call that as an open loop. When we talk about closed loop, is the one that I explained just now. When we have the reference loop, okay, you have the ECU, electronic control unit in a car. So if a car have that system, then you can actually manage to set it to the set the car to drive at a specific speed. Okay. And for the third one is the motion control. So basically, you can either want to control the motor using motor drive or numerical controller like PLC just now. Okay, so let's go to the first one, which is the electrical motor. So just read through it here. So electrical motor means that to actuate something. Same goes to pneumatic and hydraulic. So these are the three main motors that you need to know as a electrical engineering student. Okay, so you have DC motor, servo motor, and stepper motor. Okay, so what is the difference? My question is here. Okay, for DC motor, we have 2 wire. For servo motor, we have 1, 2, 3. We have 1, 2, 3 wires. For stepper motor, we have 1, 2, 3, and 4. Okay, 4 wires. So, what is for DC motor? Can you write that in the chat? What is the represent of the wire for the DC motor? DC motor je dulu DC motor, what is it? What else? Who else want to answer? Basically, the answer is in the notes, PowerPoint notes. So, I'm just asking a question to see if students read the notes earlier, before class. Just because just now I asked you to go through the slides, kan? So that's why I want to check if student can answer. Okay, Walid say power and ground. Who else want to answer? Okay, so the answer is power and ground. So basically positive and minus lah. Okay, positive and minus. Okay, so it's very simple arrangement. Okay, servo motor, what are the wire representing? 3 wires. Power, ground, and control. Okay, good. Okay, last, what is the stepper motor represent? The 4 wires. Why have 4 wires? So what does it represent? Anyone? Don't know. Okay, don't know. Later we'll go through what are the 4 wires. So, but basically the 4 wires means that you have power, 3 for power for different phases. Okay, you have basically for this stepper motor you have 3 phases. So you have phase A, B, C. So 3 means that you have 3 power wires and you have ground. Okay, so Syafiq salah lah jawapan dia. Okay, anyway, it's okay. So because we are learning chapter 7, it's okay to answer wrong right now, not to answer wrong in the exam. Okay, so if you look at the notes for DC motor, the 2 wires represent power and ground. Okay, for continuous rotation. So basically, when you connect it to the battery, okay, so it will actually turn, rotate non-stop until you take it out. Okay, so why it's important for you as a student to know, okay? Because sometimes your lecturer will give you, okay, Shafiq, this for your final year project, you use this motor, okay, to control this actuator, example, So he give you the DC motor. He give you a motor, but you do not know what is it. Is it DC motor, a servo motor, a stepper motor? Okay, so how are you going to know what type of motor is it? Any idea? Guys? Write down in the chat. How do you think? How do you identify it is a DC motor, servo motor, and stepper motor? I would suggest there are 2 ways. So for student, I want to know your answer. How to differentiate? Okay, Syafiq cakap tengok wire. Okay, good. That is one way. That's why I'm explaining the difference between the wires. So if it's 2 wire, then DC motor. 3 wires mostly are servo motor. Stepper motor, you will have at least 4 wires. Okay, what else? How other than looking at the wires, the numbers of wires, how do you actually find out what type of motor is it? Because sometimes if you're given the motor, okay, it might be a DC motor or AC motor. So the wires is the same, 3 wires. So how are you going to differentiate it? Any ideas? Size? You means you want what size? You measure the size? Okay, wrong. Basically wrong, Chu. Okay, the correct answer is that, okay, most of the time when you have a device, even your handphone, how do you check that your handphone, my handphone is Xiaomi, I'm not sure. Xiaomi apa tak. Okay, so I look at this handphone, I know that it's a Xiaomi only. Okay. But what model is it? What model? So how do you find the model? You need to find the specification. Pardon? datasheet.
Tengok ni general.
Tengok dia punya setting lah dalam ni kan. You can go to setting and so on. Okay. But if you are the owner. Okay, but yes, correct. Chu answer is correct. And Izul. You look at basically the serial number. Okay. Each of sensor ke actuator, they have a serial number. If you see here, they ada serial number. Macam example, servo motor, ST90. You go and search that, you will get the data sheet. So basically, Izul answer and Chu is correct. Okay, based on that item, look at the serial number, find the model name basically. Okay, serial number tu tak boleh sangat lah. So you look at the model name, dia SG90 ke and so on. Then from there, you can find the data sheet. And from the data sheet, it explains that it is a DC motor and so on. So that is how you find the detail. So for DC motor is that the speed of DC motor, normally you can control it using PWM. Okay, PWM ni is under the signal conditioning part. Okay, so you can control it by setting it the percentage of time spent cycling on and off ratio. So is it 50% ratio or 100% ratio and so on. Okay, of course you will have a higher speed when you have it at fully on, which is 100%. An application is example fan. Okay, fan kat rumah you. Okay, you have the fan different speed. So how does your fan actually change to different speed? So if you want to know more, then Google lah. How does my fan work? Okay, but basically you will have somewhere in your fan is a potentiometer that can change the speed depending on the ratio. Okay, ratio of the cycle. So it might be 100%. So the maximum speed is 100% fully on, and 50% is maybe at the third level or second level. Okay. And this one is how the diagram, the diagram of the electrical motor inside. So basic common diagram is that you have the rotor inside. The rotor is something that is going to move. Okay, it's going to rotate. We call it as a rotor. And the stator, okay, if you see here, stator is the one that is, as what it means, stator is something that is static. Okay, it's not going to move, so it's stationary. So stator is the one outer layer, the one in grey here. Okay, stator and rotor is inside. And mostly on the stator, you have the magnetic field, north and south magnetic field here, north pole and south pole. Okay, rotor is the one that is going to rotate, and rotor normally is going to be connected to a shaft. Okay, shaft and bearing. So when talk about shaft and bearing, is already in the mechanism part. Okay, you have the shaft and bearings. Bearing ni ball bearings lah. And shaft will normally be connected to any mechanism. You might connect it to gearing, or you want to connect it to any pulley or lead screw or spindle. So it depends on how you do the setting. Okay, what are the requirement, what the output that you want. So let me just show to you the example of what I'm talking about there, the shaft. Notes, chapter 7. Okay, look at this. Okay, this one is one actuator, rotary actuator, electromagnetic actuator that was designed by my student, master student. So if you see here, okay, the maybe cannot be seen clearly. Okay, if you see here, okay, the outer layer here, the one that have coils, is actually the stator. It is the one that is fixed. Okay, stator. And the one that you see here, inside here, there's a rotor actually. It's going to move. That rotor is connected to a shaft here, this shaft. And this shaft is connected, for the case of this setting, is connected directly. There's no gearing because we are actually designing the electromagnetic actuator to control in precise motion in micrometer displacement. Micrometer displacement. Okay, so we connect the shaft here to bearings at each side. We have the bearings here and the bearing here. And the end of the shaft is connected to an encoder or a sensor to read the rotation. Okay, so this is what the explanation is about. But this one is not a DC motor. It's basically a switch reductant actuator. It's induced based on electric, and it's going to move without any magnetic not magnetic field, without magnets. So for the case of this stator, you have the magnets. You have the north and south magnet. For the one that I showed to you, my student design, there's no magnet. Okay, it's depending on the coils just now to induce the north and south pole magnetic field. Okay, so for the DC motor, there are two types. DC motor, brush and brushless DC motor. So basically, what it means that for the brushless is that it does not have contact. For this example, underneath is the brush DC motor. Brushless is that it does not have contact. Example is like my student design is not contact between rotor and stator. Okay, so it's much more smoother. Okay, and second one, okay, this one you can just go through. Okay, DC motor. Second one is on DC motor. So DC motor is basically the combination of a DC motor. DC motor. Inside the DC motor, you have a DC motor. Okay. Then you have a gearing system inside. Then you have the controller, basically because you want to control it. And you have a sensor. So this is inside of the DC servo motor. So normally, if your lecturer give you a DC motor, okay, remember DC motor do not have any sensor inside. You need to add on buy additional encoder or sensor and connect it to the shaft. Okay, like I showed to you in this design. Okay, it's only have the motor. Then the shaft end here, you need to connect it to an encoder in order for you to read the displacement. If you don't have any sensor, then there's no displacement to be read. So you only, like DC motor, you only move it and then you cannot actually read what are the displacement. You can only see it move, rotate. So for the DC servo motor, you see that this is the DC servo motor. It's connected. The shaft is connected to what? What is this? What is this? You have learned in mechanism. Any idea?
Pinion. Yang mana yang bulat screw ni?
Yang ni. Worm gear. Oh, bukan yang pinion. Bukan. Okay, true betul. Worm gear It's a worm gear. And that worm gear is connected to a multiple gear rigging system lah. So dia ada these three gears. This gear, and this gear. Okay. And this gear is connected to another shaft, and mostly this end of the shaft is connected to a wheel ke tire and so on, and it's going to rotate. Okay. So it depends on how you do the setting. And inside this, you have encoder. So if this one is the inner part of the DC servo motor, most of the time you have a potentiometer. Potentiometer is just to detect the reference between the output and the input. Okay. So that one will be on the DC servo motor. Okay, this one just go through. And then lastly is on the stepper motor. So stepper motor, if you look at this, is basically have multiple tooth electromagnetic arranged around center gear to define the position. So it seems like what I shown here for my student design. But if you look at my student design, we only have 6 stator. 1, 2, 3, 4, 5, 6 stator. Okay. For the case of stepper motor here, you look at this, you have basically 8 stator and multiple tooth here on the rotor. So when you induce current at either A, B, C, then it's going to rotate accordingly. Okay, so let me just show you. Okay, this one. Okay, look at this diagram. So example of this stepper motor, we have only 2 phases. So you are the phase A and B saja. So let's say that we have this position. So you are going to induce current at B. B here. So what happens is that when you induce, the rotor will actually the electromagnetic will induce between the rotor and stator, and the rotor inside will rotate. So you can see that this red line is aligned with the B point, the red one, the red point. Okay, and when we induce again, phase A, you see that initially phase A is not aligned for the tooth here. Then when you use phase A, then it's going to align. So this is where when you keep on giving A, B, A, B, A, B, then this stepper motor will move precisely. And this is where you can actually directly use stepper motor to control anything in precise mode because of the precise rotor tooth. So this one is the advantage of stepper motor without adding any controller. Okay, you just control the signal through the stator there. Okay, so these are the conclusion. So based on that, okay, what I need you to do is that you have activity 4 activity. Activity 1 is that explain in the video the 3 main component of electrical actuator. Okay, which one in a Padlet, Okay, and activity 2 is that what is the difference between DC motor, stepper motor, and servo motor. So what I want you to do is that draw this type of table. Okay, I want you to don't use my diagram, find out another diagram, put it here for DC, servo, and stepper. Inside, if possible, the inside part of the motor. Physical component, what are the physical component involved? For DC motor, you have the rotor, stator. For servo motor, what else? And so on. Working principle, how does it work? So you need to explain a bit lah. Okay, and what are the application? Okay, so this is activity number 2. Activity number 3, okay, in the Padlet also, I have upload, okay. So what are the difference between AC and DC? So AC and DC, I haven't explained, but I want you to read through my notes. It's already inside my notes, and you can find additional explanation in online. Okay, so what's the difference? Same thing, construction, physical, working principle, and application. Okay, between DC motor and AC motor. Okay, and lastly is on activity number 4, okay, between induction motor and synchronous motor. Okay, so list out in terms of rotor construction, the stator construction, how does it look like, the operating principle, and application. Okay, so what I want you to do, okay, in a Padlet, okay, for activity 2, 3, and 4 is simple, is direct, So you need to actually draw out, okay, table, upload the table into this ulearn. Like, siapa dah buat? Syafiq dah buat ni. So for the first one is that video. So what example of video is like this student. This is last time the student did. Okay, you take a video and upload it.
System. First one, electrical motors. We have DC motor and AC motor and servo motor and a stepper motor. For DC motor, high torque and also high speed.
Okay, so basically, the task is to explain. I do not want student to read my notes and explain it. Read the notes and just explain it. No. I know when you are reading my notes. Okay. What I want you to do is that explain how you understand it. If you want to explain in Malay pun, it's okay. As long as you can explain it from the heart, means that you know how it works. So upload the video for the 3 different types of component in electrical actuation system. So upload that. Okay. So that will be the activity for this week. 1, 2, 3, 4. You can do it for 1 week. Next week we'll come back and look at it. Okay, as a summary. And I think that will be all for today. And don't forget to go through the slides. Basically, after the last one will be on application motor and video. So go through that slides also, because this maybe is important later on to explain your answer. And don't forget to fill in the feedback form. I opened it already for yesterday also and for today. Okay. So I think that will be all for today. Any question?
Betul, yang apa tu tune tu kena buat account ke?
Yang mana?
Yang doktor suruh
Turn it in.
masuk untuk
Yes. You log in using your email. Log in je.
email. Oh,
Yeah,
log in
you
je.
kena, you need to make an account lah. Right? If you don't have an account, then log in. You can use your email, your Gmail ke, your UTM email ke, no problem. Because later, you're going to use the turning in for your final year project and IDP as well. So might as well you start now lah. It's like a practice Okay? Okay, any more question? Because it's already 11. No Okay, if no question, then that will be all. Thank you very much So, please complete all the tasks that I give, all the activity 1 to 4, and next week we will continue, I think, for the last chapter And after that, we will discuss a few example of case study based on several different case study lah. So it might help you later for your final exam. Okay. So that will be all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Bye. Take care, everyone.